So how about if we try it again? This time we're going to create a counter class, and all it's going to have is an unsigned int variable called count. So we have already added a couple of constructors. You can see that the third function in there is a destructor. We're then going to add some traditional pre and post increment functions so that we can see how it works. And then we're going to overload the plus plus or the increment operator to not only pre-increment but post-increment as well. And then finally, we are going to overload the output stream so we can output our counter and see what it looks like. And in order to do that, we're going to need a getter for our count variable. So we'll try this class and overload the increment operators. All right, so I created the structure of a program that is going to be using the counter class so that we can practice overloading the increment operator. We're going to overload the operator as a pre-increment as well as a post-increment. Think about the pre-increment operator increments the value pre or before it's used. The post-increment operator uses it and then increments it or increments it after post it's been used, which is most likely what you're used to in your loop control variables. All right, so here we go. We're going to create a counter or a class called counter. It's going to have a single instance variable. It's going to be an unsigned int, and we'll call it count. There will be, for our public functions, there will be several constructors, and then we'll use a single destructor. We're actually going to create a couple of standard or normal pre and post or increment functions, and we'll test those out. And then we're going to overload that increment operator, pre and post, and we'll try that out. We're also going to overload the stream insertion operator so I can just see out a counter object. And in order to do that, we need to create a getter. So down here in main, I just am counting so we know in main that we are still overloading operators. So we'll come up here and we will add two constructors and a destructor. So line 18 is our overloaded default constructor that if we don't set it to a value automatically sets our count to 0. Line 19, we are going to allow them to give us an initial value. And then line 20 is our destructor for the class. So the next thing that we're going to do is we're going to create a couple of functions that use standard normalized pre and post increment. I'm going to create those inline instead of outside of the class. All right, so my pre-increment function that we're going to be using doesn't return anything at all. It is just going to pre-increment our counter variable. Remember, this is the shorthand. If I wanted to put these on separate lines, I could put it all on separate lines, or we're going to define it inline. So I will just put it all on the same line. The post-increment function is going to return the value of the counter, and then it is going to increment it. So there is an example of the post increment. Here is an example of the pre-increment. So the post increment means I need to capture the value before it is incremented, and then we are going to increment it. So then I'm going to go down into main. We're going to create a couple of counter objects, and then we're going to test out our functions. But first we should probably overload our cout so that we can display the values. So in order to overload our cout, our stream insertion operator, I'm going to create this getter called getCount, and all I needed to do is to return to me count. And then to overload the insertion operator, if you remember, this is going to be a friend function. We are going to define it and declare it and define it in here. So we're going to say that this is the O stream. We're going to use the operator keyword, and then we are trying to overload the output stream operator. There will be two parameters. The first one is an O stream operator. We will call it out, and the second one is going to be the counter object, and we will call this one C1, count 1, something like that. And we're just going to define it in here. So inside of here, all I want to do is using my output stream, we are just going to say out, and then C1 dot get count. So I'm going to use my getter to get the value of count, and then we will return out. So I needed that getter in order to be able to get the count to put in my output stream, and then we are just going to return out. So now that I have overloaded my cout, we should be able to go down into main, create a couple of counters, and then we're going to test our pre and post increment functions. So we're just going to declare some default counters, C1, C2, and C3, and then I'm going to see if my overloaded stream insertion operator is working. Let's just print a couple of them and see. I would expect the values to be 0 because I defaulted the count to 0. There we go. I probably should force some new lines inside of there to make it a little bit more readable. So in here we will end line. Run it one more time. The interesting thing is, and now I put it on separate lines, the interesting thing is this first one is the overloaded stream insertion operator, and the second one is not. That is the traditional stream insertion operator. And so it knows the difference because the value on the right hand side of that operator is an object, and so it knows to use the overloaded operator. All right, so now let's test, we'll call it the manual increment because we created a couple of increment functions, right? All right, so we're going to increment C1 dot, and we called it pre-increment. So we'll increment it once, C1 dot, and we'll increment it again. And if it started at 0, now I would expect it to be 2. And then we'll do C2 dot pre-increment, and then I'm just going to print the 2 of them now. I would expect C1 to be 2, and I would expect C2 to be 1. So we'll just print the 2 of them again. Since I already have those 2 print statements here, I'm just going to paste them down. Maybe I will force a new line before, so we can keep everything separated, and then we'll run it and see if now we have 2 and 1. There it is. So my pre-increment operator is working well because it increments it and then it uses it, or it increments it before it's being used. Now let's see if we can test the post-increment function. So I'm just going to say C3 is equal to C2.postIncrement. And if this works, C3 should have the original value of C2. And then C2, now that it has been used, should increment the value of C2. So now we want to post C3 and C2. I'm going to copy that same print statement. But now instead of coutting C1, we're going to change that to C2. And then we'll change this one to C3. And let's see what we end up with. We should probably force that inline. Let me copy that inline and force that new line here as well. All right, so now we're going to run it and see. So when I run it, I can see that the original value of C1 and C2, the original value was 1. And I captured the value of 1. And then I incremented it, and now I have the value of 2. So it looks like my post-increment operators are working just fine. My pre and post. So now we're going to overload those 2. So in order to overload the pre-increment operator, I don't need it to return anything to me. On line 38, I am going to use the keyword operator and the ++ symbol. And then all I'm going to do is pre-increment count, and it doesn't need to return anything to me. But to overload the post-increment operator, I need to return the value first before I then increment it. So on line 41, we're going to overload it in order to return a value, and then we will increment it. So here's an example. It needs to return a counter. The operator is still going to be the ++ operator. It is going to have an integer parameter that we're going to be passed to it, and we're going to increment that counter, and then we're going to return the object. So we're going to create a brand new count, or we're going to create a counter object, and we're going to set it to the value of count plus plus, and this is the counter objects that we are going to return. And our destructor, as soon as we leave this function, this will automatically destruct the object. So let's come down here and let's test out. So I have those two inline functions. We defined all of these functions inline this time. So now let me go down to main and let's test the pre-increment. So we're going to test the pre-increment overload. So how do we test the pre-increment overload? So the first thing that I'm going to do is I'm just going to display them originally because I can't remember what their values were before. I'm going to put some new lines in those text fields, and then I'm going to increment both of them, and then we're going to display them again. So I'd like to see what they were to begin with, and then we're going to pre-increment them, and we're going to display them again. I put new lines all over the place to try to make sure that it's more readable, and there you go. So to begin with, C1 and C2 were both 2s. When I pre-incremented them, they became 3s. So now we're going to test our post-increment overloaded function. All right, so beginning on line 102, I'm just going to put a statement, a header statement with a couple of new lines that we are post-incrementing C1. And then I'm going to capture the value of C1 into C3, and I'm going to post-increment C1. That means that I'm going to try to capture the value of C1 before it is incremented, because the post-increment operator then uses it and then increments it, and then I will display the value that I captured before it was incremented and the value that the value that it now contains after it was incremented. All right, so here we go. We're going to post-increment C1, and I can see that I captured its value before it was incremented, and then the post-increment, remember, uses it and then increments it. And so we see that we have overloaded the pre and the post-increment operators.